class 10 student. We are continuing periodic classification of element chapter 5. We are doing it again. I am giving you the presentation again after a long gap due to some personal problems. Sorry for that. Till today we have done Debabrata's triad, Newton's law of octaves. So we will continue from Mendeleev table, Mendeleev periodic table. Okay, Mendeleev. Even after the rejection of Newton's law of octave, many scientists continued to search for a pattern that correlated the properties of elements with their atomic masses. So Mendeleev periodic table is based on atomic masses. The elements are arranged according to their atomic masses. The main credit for classifying the elements goes to Dmitry Ivanovich Mendeleev, Russian chemist. He was the most important contributor to the early development of periodic table of elements, wherein the elements were arranged on the basis of their fundamental property, the atomic mass. So his periodic table is totally based on atomic mass and also the similarity of chemical properties. When Mendeleev started his work, 63 elements were known. Okay, you can underline this one. Right? So he examined the relationship between the atomic masses of elements and their physical and chemical properties. Among chemical properties, Mendeleev concentrated on compounds formed by elements with oxygen and hydrogen. So among chemical properties, Mendeleev concentrated on compounds formed by, he mainly concentrated his attention to the compounds with oxygen, hydrogen. He selected hydrogen and oxygen as they are very reactive and formed compounds with most elements. The formula of the hydrides and oxides formed by an elements were treated as one of the basic properties of an element for its classification. He then took 63 cards, and on each card he wrote down the properties of one element. He sorted out the element with similar properties and pinned the cards together on a wall. He observed that most of the elements got a place in the periodic table and were arranged in the order of their increasing atomic weight or atomic masses. It was also observed that there occurs a periodic reoccurrence of elements with similar physical and chemical properties. On this basis, Mendeleev formulated a periodic law which states that the element of an which states that the properties of elements are periodic function of their atomic masses. So you can write a question here. You can write like this: state Mendeleev periodic law. Okay, the question may be like this: state Mendeleev periodic law, and the answer is the highlighted area. That is, Mendeleev formulated a periodic law which says that the properties of elements are periodic function of their atomic masses. Mendeleev periodic table contains vertical columns called groups and the horizontal rows called periods. Just check out the table. So these are called row columns, So these are the coulombs. These are called groups, and these are in this direction, means in this direction it is called group. Okay, and in this direction these are called period. Okay, so atoms are arranged in increasing atomic masses. Mendeleev table was published in German journal, okay, 1972. Okay, forget it. Achievement of Mendelev's periodic law. Now we will study the achievement of Mendeleev periodic law. While developing the periodic table, there were a few instances where Mendeleev had to place an element with a slightly greater atomic masses before an element with slightly lower atomic masses. The sequence was inverted so that the elements with similar property could be grouped together. For example, cobalt atomic mass 58.9 appears before the nickel whose atomic mass is 58.7. Looking at the table, we can find out one more such anomaly. Further, so you can take it for your reference. Cobalt is placed, which is 58, appear before nickel, which is atomic mass is, okay. Further, Mendeleev left some gaps in the predictor. Instead of looking upon these gaps as defects, Mendeleev boldly predicted that the existence of some element that had not been, at that time most of the elements were not discovered, only 63 elements were discovered, so he put some gap in the periodic table. Mendeleev named them by prefixing Sanskrit word ikka. He called it as ikka. Ikka means one. The naming of preceding in the same group. For instance, scandium, gallium, germanium discovered later have properties similar to ikka boron. Okay. So, for instance, you can copy this thing. You can silicon, okay, ikka aluminum, ikka boron, ikka aluminium, and ikka silicon. The properties of ikka aluminum predicted by Mendeleev and those of the elements gallium, which were discovered later, replaced ikka aluminum, are listed. Okay. Listed. So atomic mass ikka aluminum is 68, and it is, instead of ikka aluminum, it is after later it was named as gallium. Formula of oxide Fe2O3 ikka E2O3, which was named as gallium oxide. Formula of chloride ECl3 ikka Cl3, which is gallium chloride. This provides convincing evidence of both the correctness and the usefulness of periodic table. Further, it was extraordinary success of Mendeleev's prediction that led chemists not only to accept his periodic table but also recognize him as the originator of the concept on which it was based. Noble gases like helium, neon, and argon have been mentioned in many contexts before this. These gases were discovered very late, because they were very inert and present in extremely low concentration in our atmosphere. One of the strengths of Mendeleev predictability was that when these gases were discovered, they could be placed in a new group without disturbing the existing order. So what is the limitation? Means how far we can use the predictable, we will discuss now. Mendeleev predictable. So we'll discuss the limitation of Mendeleev's classification. Electronic configuration of hydrogen resembles that of alkali metals. Like alkali metals, hydrogen combines with halogen, oxygen and sulfur to form compound having similar formula as shown in the figure. So HCl, NaCl, like it is a compound for NaCl, H2O, Na2O, H2S, Na2S. So sodium is an alkali metal and hydrogen just react like, form compounds like alkali metals here. So on the other hand, just like halogen, it also acts like halogens also. Hydrogen also exists as diatomic molecule. It combines with metals and non-metals to covalent compound. Certainly no fixed position can be given to hydrogen in Mendeleev's predictor. This limitation. So the first limitation is this. Okay, he could not assign a correct position to hydrogen in this table. Isotopes were discovered long after Mendeleev and had proposed his predictive classification of element. Let us recall that isotopes are elements having similar chemical properties but different atomic masses. This has isotopes have different masses but having same chemical properties. So thus isotope and elements posed a challenge to Mendeleev's predict law. Another problem was that the atomic masses do not increases in a regular manner in going from one element to the next. So it was not possible to predict how many elements could be discovered between two elements, especially when we consider the heavier elements. Okay, these are the limitations of so question may rise like this. Write down 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 Mendeleev's predict TA value. Okay, so the question arises here like this. Write down the limitation of Mendeleev's predictor. So this is whatever line, the lines highlighted with yellow color, you can write down. So for today we'll stop here and we'll continue with modern predictable in the next session. Thank you very much.